These next two problems give us a chance to practice our new vocabulary for this section. So I have a velocity function here, a car is traveling along a straight road. I have a time interval, 0 to 24 seconds. I know the velocity is given by this piecewise linear function that's in the graph. Notice it's my job to notice what this is a graph of. This is a graph of velocity. So find the integral from 0 to 24 of v of t dt, and using correct units, explain the meaning. You could answer, there's two questions in there. So this is one part of one problem, and there are two questions within this part. Feel free to answer them in either order. You could get credit for one, even if you don't know how to do the other. So the integral from 0 to 24 v of t, I don't have a v function to integrate using algebra, to integrate with an antiderivative, but I know that I can find area. The area between the v of t curve and the t-axis between time 0 and 24. So I'm going to write, this is the integral from 0 to 24 of v of t dt equals, I'm going to write an expression for the area of a trapezoid. If you want to break this up into a rectangle and two triangles, that works too. They both get full credit. We should get that same answer either way. I'm going to write the distance across the top is 12. Distance across the bottom is 24. I take the average of the base as the average of the parallel sides. I'm going to multiply by whatever the other dimension is, the distance between the parallel sides, that is 20. That's a great answer. You could circle that and get full credit for the first part of their question. That is the value of the integral from 0 to 24 v of t dt. Did I do this problem already with you? So it's 36 halves 18 times 20. Is that 360? Yeah. Okay, so, and then this next part, using correct units, explain the meaning of that integral. So I'm going to write this out in words. They are looking for four things when you write this answer. So I'm going to write the integral from 0 to 24 of v of t dt is, or represents, is. They want to know the quantity that it represents, the units of that quantity. They want to know the, in this case, think about the limits of integration. What variable do those represent? What quantity do those represent? And can you give units on that? So there's four separate parts. Two different quantities, two different sets of units. Is. Okay, so what is it? This is the area under velocity curve. That's displacement. In this case, notice our velocity is always positive. That's the same as distance traveled or total distance traveled. So I would expect on this problem you would get full credit for writing displacement, distance traveled, total distance traveled, because in this case they all happen to have the same value because our velocity is positive. But technically speaking, this is displacement, is the displacement of the car, or you could say the car's displacement in, what are my units? That was, velocity was measured in meters per second, and my time units were in seconds, so meters per second times second gives meters over the time. Let me type this for you. All right, that's better. I typed it up for you. So the integral from 0 to 24 of v of t dt is the displacement of the car in meters over the time interval t equals 0 to t equals 24 seconds. So I'm just going to highlight this because they are looking for four things in this answer to give you full credit. And it's usually, this statement here is usually only worth 1 point. So if you miss any one of those four things, you get no point, even if you've understood what this value that you've evaluated means. So watch. The displacement, so what quantity does that represent? Well, I've integrated velocity, that gives displacement. And I need units on displacement. And I need to give information about the input. It's not any displacement of the car. It's specifically the displacement of the car over the time interval. So think about what your limits on your integral, what quantity they represented. They were t values, and t in this problem represents time. So this is the second quantity, and I have to give units on that quantity. Notice I have to specify the limits on the integral. So it's not that it was the displacement of the car over anything except this time interval specifically from 0 to 24 seconds. Make sure you have all 4 parts to get full credit for that answer. Most people, they get lazy and they leave off the seconds, which is the easiest part. Don't be that person. All right, I have a similar problem here. So just notice that's very typical. I would say almost guaranteed that you would see a velocity graph or maybe a position or acceleration graph on the free response section and have to answer questions about the relationship between position or distance traveled, velocity, and acceleration. So here I have a particle moving along the x-axis. Again, I've been given the velocity. I've been given, an interval, a time interval on which that velocity function is good. Notice here I've been asked to call the position function x of t, and I know that the position of the particle when time is 0 is 5. Notice that doesn't show up in this graph because this is a graph of velocity. It's not going to tell us about initial position. That's why they had to tell me separately that initial position is 5. So find the total distance traveled by the particle from time 0 to time 3. This is a calculator question on the free response section. This is the integral I expect you to write. I'm going to write it up here so I have lots of room so I can make my notation big enough that you can read it. So total distance traveled, again, there's no special notation for that. It's going to be the integral from the time interval I was given, 0 to 3, the absolute value of the velocity. Don't forget your dt. If you write that integral, look, you don't even have to write out what the velocity function is. That should be the velocity function in absolute value bars with the correct limits of integration and without forgetting your d of t. That's worth a point. If you type it into your calculator correctly and get the correct answer, which I will type into my calculator momentarily, that's the second point. This is 2 points. It took us 45 seconds. And that's equal to 1.702. Again, remember, you have a list of, like a menu of calculus functions on your calculator that you get with the alpha key followed by the F2 key. And the absolute value function is the first one in that list. This next question, find the position of the particle at time 3. So there's 2 ways to think about this. I'm going to show you both. There's a fast way and then there's a longer way, but the longer way you're going to need for some other later problems. So just think about them both. We said final position is original position plus displacement. So our final position for the particle is going to be the original position, we said, which was 5, plus displacement. Displacement is the integral over the correct time value, that's time 0 to 3, of the velocity. Again, this is a calculator problem. You type that into your calculator and you get 5.773 or 5.774, depending on whether you round. Remember, you can choose to either truncate or round at the 3rd decimal place. Your choice. They actually publish both answers in the score guide if they're different. So another way I want you to think about this, think of this as a most important example in chapter 5 problem. So there might be another problem, like a similar problem, where instead of asking you to find the position of the particle at time 3, they ask you to write the position function. So think about what we know about the position function. We know the velocity function, which is position's derivative, and we know one ordered pair. We can use the most important example in chapter 5, kind of set up to write an expression for x of t, the position function. So x of t is going to equal the integral from The position I know is time 0, so 0 to t. That upper limit should be a variable and match that input variable. And this is the velocity. I can't use t though, I have to give some different dummy variable, so I'm going to use v of p dp. And my initial value, that 5, is going to end up out here. So if I were to replace time t with 0, I would have 5 plus the integral from 0 to 0, which would give me x of 0 equals 5. And if I took the derivative of x, I would get x prime, which is supposed to be the velocity. And the derivative of 5 would be 0. The derivative with respect to t of the integral from 0 to t of v of p dp is just v of t. So this is an appropriate expression for x of t when you want x of 0. Nope. What do you want? You want x of 3, the position at time 3. You would be able to take this function you wrote, this x of t function, and simply replace t with 3. X of 3 is going to be 5. That's an equal sign. Let me make that a better equal sign. Equals 5 plus the integral from 0 to 3, v of t dt. And you get the same answer, 5.773.